All right, good morning. So this is the lesson for today, Tuesday. We're jumping around a little bit. We're going to go to Parabolas, which is page 260. We're going to go 260 to 263 in your packet. So take that out. Remember our definition of a circle. The definition of a circle was you've got one fixed point. It's the set of all points in a plane that are equal distance from that fixed point. So imagine I could have a string that was the same size and just pull it in every direction, the same distance, because a string is a constant length. Okay, and you would get a circle. So that was your geometric definition of a circle. Okay, so our geometric definition of a parabola, it's the set of all points in a plane that are the same distance, not just the same distance from a point, but the same distance from a given point, which we call the focus, and a given line, a fixed line, called the directrix. Okay, these quadratic relations have only one squared term. So remember, a circle, equation for a circle was x minus h squared plus y minus k squared equals the radius squared. Okay, you had an x squared and a y squared, always. Okay, so let's first think about what this means. Set of all points in a plane that are the same distance from a given point as they are from a given line. Okay, so let's just draw a point. I'm going to call this my given point. I'm going to call it F for focus. And I could draw a given line. I could draw it anywhere. Okay, so I'm going to draw it. Let's say I were to draw my fixed line here. I'm going to draw it as a dotted line, just so to remind us that this line is not actually part of the parabola, but it helps us to determine the parabola. And I want all the points in this plane that are the same distance from this point as they are to this line. Okay, this line is called the directrix. Okay, so the first point I can draw that's equidistant from these two would be right in the middle. And this is a very important point. This ends up being our vertex. Now, as I move away from this point, let's say I were to move this way. And when I get over here, is this point now the same distance from this line? Remember, distance from a point to a line, you always take the shortest possible distance, or the perpendicular distance. Is it the same distance to the line as it is to this? No. Okay, so see how as we move away from the vertex, if we're moving parallel to that line, we're staying the same distance from here, but we're moving further away from there. So in order for this point to stay equidistant from this point in this line, it's got to start moving away. So maybe about here. Let's see if that looks about right. Does this distance look like it's the same as this distance? And that looks like those might be about equidistant. As I move further away, oops, maybe you can't see that now. This distance has to be equal to this distance. Okay, so as you move further away from this vertex, you're also moving further away from the line. Same thing happens as you go in this direction. Okay, and as you can see, what we get a parabola. You could pick any point on this parabola, and the distance from the fixed point, from this point, any point x comma y, to your focus should be equal to the distance to your directrix. Okay, I just freehanded that, so they might not be perfect, but every point on this parabola should be equal distance from the focus as it is to the directrix. Okay, and now we're going to derive the formula. And I know you already know the definition or the standard vertex form for a parabola, but we're going to derive it. So this one, here's your fixed line. This is your directrix. And notice, keep in mind, when I drew this one, I drew the point here, and I drew the directrix vertically and to the left. And that made my parabola open to the left. It's going to open always away from your directrix because you're not going to cross the directrix. If you cross the directrix at some point, your distance, your point to the directrix would be 0. You don't want that because it needs to be equal distance from here as it is to this fixed point. And it can't be, that distance from both can't be 0 unless these were on top of each other. Okay, so I'm going to call this thing my directrix, and I'm going to make the focus equal distance from the origin in the other direction. So this is going to be my focus. That way, this point right here at 0, 0, that point is equidistant from my fixed point and my fixed line. This point, as you can see from this picture, that point is your vertex. So that's your vertex of your parabola. And this specific distance from the vertex to focus and the distance from vertex to directrix, remember these are congruent because it's equal distance. That's a very specific and important value. We're going to call that P. Okay? This distance is P, and this distance will also be P. Okay? So we're going to say P is the distance from the fixed point, the focus, P is the distance to the vertex, and also the distance from the vertex to the directrix. So the distance from the focus to the vertex is P, and the distance from vertex to the directrix is also P. So P is the distance focus to vertex, but also vertex to directrix. Okay. Now I want you to notice one more key thing that we're going to draw on here. Well, actually, we'll come back to that in a second. I'm going to draw, actually, we'll do that now. The distance, if you think about this distance from the focus all the way to the directrix, that's 2p, which means if I now travel parallel to the directrix and I go that same distance, 2p, let's say we go about there, same distance here, 2p, those are two very important points. Now notice, you will make a square here, because this distance for this point on your parabola, x comma y, any point x comma y, that distance to the focus has to equal the distance to the directrix. We know that this distance is 2p, because that's 2p. Basically, we've made a square. So this distance, by definition, has to equal this distance. Okay? And since this is 2p, this is also 2p. Okay, so that's 2p, because p plus another p. 2p is also known as the focal radius. And then if you actually go from this point all the way to this point, that distance here would be 4p. 2p this way, 2p this way, 2p that way. 4p is also known as the focal diameter. Kind of makes sense. Diameter is usually twice as big as the radius, but it's a focal radius and a focal diameter. Okay. Now let's go back to deriving our formula. Let's take any point xy. I'm not going to take this one just because that one's a very specific point. Let's take a point over here. For any point on your parabola, x comma y, the distance, this distance, d1, has to equal this distance, d2. That's our definition. Any point xy on your parabola, the distance from the focus has to equal the distance to the directrix. So let's figure out these two distances. This point here, I know it's on the y-axis because of where I drew everything. Okay, so my x-coordinate is 0. My y-coordinate, I'm going up p. This is the point 0, comma p. This point right here, well, we can figure out this point too. The distance I move in the x direction, well, that's going to be the same as this x-coordinate, so I'm going to call it x. My y value, over x, I'm going to go down this distance, which is p. So x comma negative p. Okay? So this point is x comma y, this point is 0 comma p, and this point right here is over x, same as this x, and then down this distance, down p. Okay, and I need to set d1 equal to d2. Okay, so d1 equals, we can use the distance formula, square root of x1 minus x2 squared plus y1 minus y2 squared. So x minus 0 squared plus y minus p squared is equal to d2. Now d2 is this distance. Okay, and this distance is, you could subtract the absolute value of y2 minus y1. So we could do y minus negative p or y plus p. Now, so you notice you don't have to do a distance formula here. You're just finding this distance. And this distance from here to here is p. You know, that's p. And this distance from here to here, well, that's our y value. So this distance should be the y value plus p. Okay, you could use the distance formula. The x's would go away. You'd get the square root of y1 minus y2 squared plus x minus x1 minus x2 squared. Okay. Now let's solve this thing. Let's square both sides. So we get x squared plus y minus p squared equals y plus p quantity squared. Okay. Let's FOIL that. X squared plus, we get y squared minus 2yp plus p squared equal to, FOIL this, y squared plus 2yp plus p squared. We can now subtract y squared from both sides. Those go away. We can subtract p squared from both sides. Those go away. Okay. So we're going to get x squared on this side equal to, I'm going to add 2yp to the other side. So add 2yp to both sides, and I'm going to get 4yp. Solving this thing to get the y by itself, we get y equals, 4p goes on the bottom over here, 1 over 4p times x squared. Look familiar? That's your definition. That's your vertex form of a parabola with the vertex at the origin opening up as long as p is positive. And this is your a value. This thing in the past was always your a value. Okay, so standard form for parabola, what we've seen in the past was y minus k equals a times x minus h quantity squared. The vertex is hk. Now, this a value we now know is 1 over 4p. The reason we're going to call it 1 over 4p is because 1 over 4p has more meaning to us. The p value has a meaning. P is the distance from the focus to the directrix, this distance here. And p is the distance from the, focus to the vertex and vertex to the directrix is your p value. Okay, so this one, and we're going to say there's a plus or minus here. P by definition is a distance. Okay, so p is positive, but there could be a plus or minus. The plus means it opens up, the minus means it opens down. So if it's in this form, it opens up or down. Based on if you have a plus or minus here. Okay. Now, if it opens right left, well, now notice we said one of the terms is squared. Here, the y is not squared and the x is squared. Okay. So the y is not squared, the x is squared. Whenever that happens, think about the first parabola you ever saw, y equals x squared. That opened up, right? Y equals negative x squared, opened down. The y was not squared, the x was squared. Okay. Now, if you switch these, you've got x minus h equals plus or minus 1 over 4p times y minus k squared. This one's going to open right or left. Okay. Right if this is a plus in front of here, and left if this is a minus in front of here. Okay, so x equals y squared was a sideways parabola. Okay, and we're going to practice some of those. Now, if you want to put this k over to the other side so it looks more like the form that we had back in chapter 5, that's fine. If you want to move this h over there, that's fine. I like to keep them together, okay, because remember the h is always with the x because the h is the x coordinate of your vertex. The k is always with the y because the k is the y coordinate of your vertex. Okay, so with the vertex, we could say the vertex is always h comma k. That doesn't change from our definition back in chapter 5. Okay, so let's just go through some of this stuff here. Determine the direction that each one will open. Okay, so you're just going to say up, down, right, or left. Well, we have an x equal to a y squared. When your x is not squared and your y is squared, it's going to be right or left. Okay, now you look at your a value or your 1/4 value. There's a minus. So it's not right, it's left. Opens left. Y equals x squared. The y is not squared, the x is squared. That means up, down. Our a value, or the 1/4p, is positive, so that's going to open up. Y equals negative 8x squared. Y is not squared, the x is, so it's up, down. That value is negative, so it's going to open down. X equals y squared, so it's right, left. Your a value is positive, so it's going to open right. X equals y squared, that opens right or left. A value is negative, so it opens left. Y equals x squared, up or down, your a value is positive, so it opens up. Okay. Let's go to the next page. We're going to do a couple more pages here. Okay. Now, given the equation of the parabola, determine the direction each parabola will open, then find its vertex in the axis of symmetry. So your axis of symmetry, I didn't really talk about that, but we remember from chapter 5, our axis of symmetry is this line right here that passes through the vertex. And now we know it's also going to pass through the focus, okay? Where all your points on your parabola have symmetry. It's like a mirror. Your axis of symmetry is like your mirror, and this will look identical reflected over that axis of symmetry. So if it opens right or left, your axis of symmetry is a horizontal line. If it opens up or down, here your axis of symmetry was just the y-axis. So your axis of symmetry will be vertical. Okay. The axis of symmetry always passes right through your vertex. Okay, so the direction, y equals negative x squared, that opens down. The vertex is negative 4. Now if you put that 1 with the y, it'd be y minus 1. So negative 4 comma 1. The axis of symmetry, it's y equals x squared, so it's vertical. So x equals the x coordinate of your vertex, negative 4. Okay, I'm going to walk through all these. If you want to pause the video and work through these and then just fast forward and check your answers. But I'm going to talk through each of them. X equals y squared, so that opens right, left. This value is positive, so it opens right. Your vertex is going to be, that would be, if 6 was with the x, it'd be x minus 6, so 6 comma 1. And it opens right, left, so your axis of symmetry is going to be y equals the y coordinate of your vertex, y equals 1. Okay. This one, the vertex is 0, 0. It's going to open up. And your axis of symmetry is just x equals 0. Next one, x equals negative y squared, so that's going to open left. Your vertex is 4 comma negative 9. Sometimes it's nice to put that x with the 4, so you see x minus 4 equals negative 3 y plus 9 squared. So you know 4 and negative 9. So it's x minus h and y minus k. Okay. This opens right, left, so our axis of symmetry is horizontal, passing right through your vertex. So y equals negative 9. X equals negative y squared, so that's going to open left. Your vertex is 5 comma 0. Y equals 0. And y equals x squared opens up. The vertex is 1 comma 7. And then x equals 1. Okay. Now write the equation of a parabola given the focus at 5, 5 and a directrix at y equals negative 3. Right? The easiest way to do these is to graph them and kind of think it through. Remember your definition that we did on the other page. Remember what P means. Okay, equation of parabola, focus at 5, 5. Draw it this way. And my focus is at 5, 5. Maybe I should do that a little bit further down. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I like to label my points, especially when I'm drawing a graph freehand. That's a focus. The directrix says y equals -3. Okay, so we need the set of all points that are equidistant from this fixed point and this fixed line. You find the midpoint of these two, equidistant. This is 5, 6, 7, 8, 8 away, so we'll go 4. This is going to be our vertex, which is at 5, 1. Now, I always like to draw that focal diameter and the focal radius. This entire distance is 8, so I know I want to go 8 in this direction. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that point right here is going to be, if I go 8 more, I'm at 13, 5. If I go 8 in the other direction, I'll be at -3, 5. Okay, so you know that this is going to look like this. Okay, just remembering that this point, any point on here, has to be the same distance from the focus as it is to the directrix. Here we go 8 that way, and we go 8 this way, where the focal radius is equal to 2 times p. P plus another p. Remember, your p value is this. P is 4. This opens up, so the general equation for a parabola that opens up is y minus k equals +1 over 4p times x minus h, quantity squared. Let's plug in our vertex. Our vertex is 5, 1. So y minus 1 equals 1 over 4p times x minus 5 squared. And our p value is 4. So we're going to put in a 4 for p. So our equation is y minus 1 equals 1 over 16 times x minus 5 quantity squared. Remember, when that a value gets smaller, your parabola is opening wider. So you can kind of see what's happening now. When your p gets bigger, your denominator is getting bigger, which means your a value is getting smaller. So when p gets bigger, the further away your focus is from the directrix, the wider it's going to open. And as these get closer together, you're going to get a parabola that opens much more narrow. Okay. Let's go to the next one. Write the equation of parabola, vertex at 6, 2, and directrix at x equals 4. One, 2, 3, 4, 5, 6, 2. That was the vertex. Be careful. They try to trip you up. They give you a different value, but they'll always tell you what it is. Vertex is 6, 2. And then x equals 4 is your directrix. Now the vertex is here. That's a point on your parabola, which has to be equidistant from this and the focus. So the focus has to be to the other side. It's going to be 2 over here. Your focus is going to be, if we go 2 right from there, we're now at 8, 2. Okay, so this distance, so we know that p is equal to 2. P is the distance from vertex to focus and vertex to directrix. So we know p is 2. They gave us the vertex. They gave us the directrix. Okay, now I'm going to find that total distance, 2p, which is 2 times 2, 4. And I'm going to go 4 up and 4 down. 1, 2, 3, 4. So that's going to be 8, -2. I'm going to go up 4, which gets me to 6. So 8, 6. And that's going to help you draw. Okay, and just double checking the distance from any point on here to the focus. Well, that was 4. Between 2 and -2, that was 4. And this distance here, these have to be equal. Okay. Okay, so this opens to the right. And if your parabola opens to the right, it's going to be x minus h equals, and this is right, so positive 1 over 4p times y minus k squared. My vertex is 6, comma 2. So 6 is h, 2 is k, p is 2. So I've got x minus 6 equals 1 over 4 times 2, so 1 over 8. And then y minus 2 squared. Okay. Okay, let's go to the next one. Given that y equals -1 over 8, x minus 3 squared plus 5, find the vertex, focus, axis of symmetry, equation of the directrix. Okay. So y equals -x squared, this opens down. Even though they don't ask us that, that's always going to help me, down. The vertex is going to be 3, comma 5. The axis of symmetry, since it opens down, up or down, it's going to be vertical. So x equals 3, the x coordinate of your vertex. Now, I always like to draw these. So our vertex is at 3, comma 5. It's just a quick sketch. 1, 2, 3, 1, 2, 3, 4, 5. Okay. I know that this opens down. Now let's find my p-value so I can plot everything. This right here is my vertex opening down. So I know you're always going to open towards your focus and away from your directrix. So I know my directrix is up here somewhere. I know my focus is down here, okay, because it opens down. So p is, let's find p. Once we set this thing, 1 over 8 equal to 1 over 4p. So remember that coefficient of your squared term, your squared quantity, is 1 over 4p. Notice I didn't make it negative. You can leave the negative if you want, but really the negative, the p-value is a distance. So your p by definition should be positive. Some books will make p negative, so I don't really worry about that. You're just going to set this quantity equal to 1 over 4p, and you can see that p equals 2. So that means you're going to go down 2 to find your focus. The vertex was at 3, comma 5. If I go down 2, my focus is at 3, comma 3. I'm going to go up 2 and find this equation of the directrix, which is going to be y equals 2 up from 5, so y equals 7. And focus is 3, comma 3. Okay, I'm a visual person, so I like to draw this. You don't have to, but if you want to finish drawing, you go 4 left, 4 right. You get something that looks like this. Okay. Next one, given the equation y